Similar to autoencoders, GANs consist of two neural networks, a generator G and a discriminator D. At the beginning of our architecture, we have a random noise vector C that we sample from a normal or a uniform distribution. From this random vector C, the generator generates fake data, which we also denote as G of C. If we want this data to be images, for example cats, we could make use of transposed convolution. Next to the fake data, we have real data, which we take from a dataset. The discriminator now takes either fake data or real data as an input, and its job is to predict whether the input is real or fake. So a good discriminator would predict for our real data x a value of 1, indicating that the data is real, and for G of C, so for our fake data, the discriminator would predict, if it's good, a 0, indicating that it's fake. And so in short, the generator is trying to fool the discriminator with fake data, and the discriminator is trying not to be fooled. And this adversarial relationship gives then rise to the name generative adversarial networks.